All right, now we're going to do a parallel circuit lab with the same equipment that we've been using. So we're still going to use just coils 2, 3, and 4 like we did in the series circuit video. Coil 2, 10 meters of 28 gauge copper wire, 20 meters of 22 gauge copper wire, and coil 4, which is 20 meters of 28 gauge copper wire. We're first going to measure the current and the voltage for each coil individually. That way we can determine their resistance before we start putting different elements in parallel. So we're going to start off with coil 2. Powering on. We are on the 1 amp scale. So there is the voltage and the current for coil 2. Powering back off. Switching to coil 3. Powering back on. Now on this one, the needle has spiked. It's gone all the way across. So that means I need to change back to the 5 amp scale. So for the 5 amp scale, we're going to use the bottom set of numbers. Turn the power back on. There's our voltage. And here's our current. Remember, we're on the 5 amp scale, so we're going to use the lower set of numbers, and each line is worth 0.1 amps. Powering back off. Move into coil 4. Now on this one, the current seemed low enough that I want to switch back to the 1 amp scale. Powering back on. So that's my voltage and my current for the 4th coil of wire. Remember, we're on the 1 amp scale, so we're using the top set of numbers, and each little line is worth 0.02. Powering back off. Now, to wire things up in parallel with this system, I am going to put these 2 leads as if we were going to test coil 2 by itself. And then what I'm going to do is I want to use another wire to connect from where the current goes in to the far side of coil 3. And so what happens is now the current leaves here, goes to this point, and that's a junction, and it splits. Some of the current will go through coil 2, while other bit of the current will go through this wire and into, I guess we say, the back side of coil 3, and it'll go this way. They'll both recombine here and then go out to the other side of the DC power supply. So now coils 2 and 3 are in parallel to each other. And I'm going to go ahead and switch over to the 5 amp scale. So we're going to use the bottom set of numbers, and each little line is worth 0.1. Turning the power back on. There's our voltage and our total current through this parallel circuit. Powering back off. Now to get coils 2, 3, and 4 up in parallel, I want to take another jumper wire and connect from here to this post. Now, when the current comes out of the DC power supply, it'll go to this junction. Some of it will go through coil 2 and then back out. Some of the current will go through this jumper wire into this junction where the current will go through here. Some of it will go through this coil of wire and then back out. Some of it will go through this coil of wire to here and then through this jumper wire back and then out again. So this puts coils 2, 3, and 4 in parallel with each other. I want to stay on the 5 amp scale, powering on. On the 5 amp scale, remember we're using the bottom set of numbers. There's my voltage, and that is my current. Now, you can compare the resistance of each individual resistor coil to what they should be in parallel and compare the answers. Powering off, and that's a parallel circuit. Thank you.